From World War dogfights to supersonic stealth jets, air superiority has always defined modern warfare. But now, a new era is unfolding. An era where pilots are optional, AI makes split-second combat decisions, and battles are fought from space and beyond. This is not science fiction. This is the future of aerial warfare. Military aviation and space have seen the fastest evolution. Air power played a significant role in Korea and Vietnam. Arab-Israeli and Indo-Pak wars saw conventional peer-level operations and gave out solid lessons. Iraq and Afghanistan were uncontested battlegrounds. And now Ukraine, Hamas, and Houthis have driven importance of cheaper drones and air defense systems. Clearly, aerial technologies and their impact are reshaping the future wars. The last century has seen aerospace becoming the most preferred means of prosecution of war. The continued need for air and space superiority to allow favorable prosecution of air, surface, and subsurface operations remains underscored. The combat aircraft have become more agile with characteristics of high speed and maneuverability, delivered with greater efficiency. Aerial platforms have become stealthier and support low observable sensors, are able to see and sense farther. Aircraft can carry and deliver very long-range air-to-air and air-to-surface precision weapons. The aircraft's ability to operate in an intense electronic warfare environment has increased. Fighter aircraft attributes such as very high speed and maneuverability will be less important compared to range and precision of sensors and weapons. Integrated sensors across platforms coupled with secure data-linked communications have allowed the system of systems approach. Artificial intelligence, AI, supports speedier decision-making. The next-generation aircraft have to be designed for a highly contested and well-defended environment. The combat engagements will be at very long ranges. Platforms that seeing first, shooting first, and destroying first, and yet are survivability. They will be multiple role and carry weapons for both air-to-air and air-to-surface targets. Aircraft should be able to act as motherships or controllers in a manned-unmanned teaming mix. Aircraft will be closely integrated and securely data-linked with other platforms in the air or on the surface. Artificial intelligence, AI, will support aircrew's cockpit housekeeping chores and generate weapon firing solutions. Data-to-decision, D2D capability will be crucial. Human-machine interface will improve greatly. All-hemisphere situational awareness will allow more comprehensive threat assessments and response options. Futuristic avionics will include agile advanced electronically scanned array, AESA radars, and passive data-linked sensors. Aero engines will be flight phase adaptive, more fuel efficient, and feature thrust vectoring and inbuilt supercruise. Stealth will be inbuilt in the airframe design through advanced shaping and skin layering techniques using composite materials, without adding weight or trading in flight performance. Engine inlet and exhaust will be designed for low radar cross-section, RCS, over the entire spectrum of frequencies. The conformal weapon bays will carry very long-range weapons. Weapons will have increased degree of post-launch autonomy. Enhanced onboard power generation will support powerful electronic warfare systems and DEWs. The aircraft will incorporate preventive maintenance tools and online health monitoring and diagnostics with inbuilt structural self-healing materials. Some technologies may sound weird, such as sweat-powered electricity, touch-here text recognition, solar-power generating canopies, subdermal nutrients, adaptive camouflage, or quantum stealth, magnetic flux generator to fire projectiles, coil guns, self-steering smart guided bullets, among many other technologies. Future missiles will have long-range detection, cruise farther, and have high no-escape zones. All countries are pushing advanced hypersonic weapon programs. The U.S. Air Force, along with Raytheon, is working on a mini-missile that can shoot down incoming air-to-air and surface-to-air missiles as part of the Miniature Self-Defense Munition, MSDM, program. New turret systems will allow high-energy lasers to engage enemy aircraft and missiles. Standalone high-energy laser weapon pod for being designed. The U.S. Air Force Research Laboratory, AFRL, is developing a fiber laser system called Self-Protect High Energy Laser Demonstrator, or SHIELD. It could daze or burn electronics of other airborne platforms. Hypersonic cruise missiles, HCMs, have already been used in combat in Ukraine. Hypersonic glide vehicles, HGVs, and HCMs will bring game-changing vulnerabilities to strategic targets and large ships and aircraft carriers. Large platforms like the Airborne Early Warning and Control, AEWNC, and Flight Refueling Aircraft, FRA, will kept farther away from tactical area by long-range missiles. India's Astra Mk1 110 km AAM is operational. Mk2 160 km is under development. The Very Long Range VLR AAM Mk3 will have range over 300 km. The air-launched BrahMos missile, 500 km, has been integrated on the Su-30 MKI. Longer-range variants are evolving. The hypersonic version, BrahMos 2, began testing in 2024. The later variant will have ranges up to 1,500 km. DEWs are work in progress. Drones and uninhabited systems are already flying in large numbers. Optionally manned aircraft are evolving. Autonomous UAS are operating from aircraft carriers. The next generation UAS will be able to take on IST, surface strike, air defense, aerial refueling, and air delivery. By the mid-2040s, it is envisaged that every aerial mission could be flown unmanned. Aerial drone swarms have been repeatedly demonstrated, including by Indian manufacturers. Swarms could overwhelm defenses by sheer numbers. Drone counters using small arms, electro-optical weapons, laser, data link jamming, electronic or cyber attack are evolving. A drone swarm may be engaged by a counter-drone swarm. Some of the key technologies will include development and manufacturing of nanoscale, smart metamaterials, and advanced composites. Special coatings will require high-specification machine processes. Some critical minerals will be required for future materials. Platforms will use advanced magnets and superconductors. Additive manufacturing will grow. AI will influence all aerial technologies and support hardware accelerators. High-performance computing and communications technologies will see more applications. Advanced data analytics and machine learning excellence will evolve. Cybersecurity will be critical. Advances in hydrogen and other hybrid fuels and electric batteries will matter. Nuclear energy could one day power aerial platforms. Quantum computing and cryptography applications will evolve. Hypersonic flight and weapons will advance. Drones, swarming, and collaborative robots will be used extensively.